Hi. I am going to try to help with this Riemann sum question. Let's make sure that we write down what the question is. The question says, where did you go? The question says, find the integral of from -2 to 0 of 5x squared plus 5x dx using the official definition of the integral. Okay, so we're going to approach this problem, and the first thing we need to do is remember what the definition was for the integral. It was the limit as n goes to infinity of the sum from I equals 1 to n of f of x I delta x. All right, and we have to remember what these are. This is the height of the rectangles, and this is the width of the rectangles. So let's first figure out what the width is. So remember what we're going to do. We're going to set up our interval and break it up into n tiny pieces. So in this case, we look at the bounds, and the bounds go from -2 to 0, and we're breaking this up into n pieces. This is x0, x1, x2, ... This is xn. And then we have some function here lying over this. I don't know exactly what it looks like, but let's just pretend it looks like that. And what we need to do is we have to figure out what the area of each of these rectangles is. Okay. Whoa. Hello. Out of focus. What just happened there? How about that? Sorry about that. Wow. Wasn't expecting that. Okay, so we have, so now let's figure out first what the width is. Now the width is the total width of this, so 0 minus -2. This is the width of total width of the interval. And then the number of pieces is n. So this delta x is going to be 2 over n. Now we need to figure out what these values are. So we've figured out what delta x is. Now we need to figure out what the x of i's are. And those correspond to the right endpoints of each of these intervals. So we need to have a formula. We need to know what is x1, what is x2, what is x3, etc. What is xi? So x0 is just the right endpoint, so it's -2. x1 is what happens when you go for the negative endpoint, and then you add in delta x. So you get -2 plus 2 over n. Now we add in another delta x, -2 plus 2 times 2 over n. And then the last one, the x3, was -2 plus 3 times 2 over n. And so in general, if we're over here at x sub I, figuring out what the width, the endpoint is here, it's -2 plus I copies of delta x, 2 over n. Okay, now this is good because we're going to take this xi and plug it in here into the equation. So what that means is what we're going to look for, this area, is going to be the limit as n goes to infinity of the sum from I goes from 1 up to n of f of xi -2 plus I times 2 over n times 2 over n. Now this function is this function that's in the integrand of the function. So let's simplify this. Let's actually plug it in and see what we get. Sum I equals 1 to n of f. So 5 thingy squared plus 5 thingy times 2 over n. Now, the first time I did this problem, I forgot that, and it led to me having having to go back over, make mistakes. But you know, that's what happens. You have to make mistakes along the way, and then you learn from them. Okay, sum I goes from 1 to n. Now we need to expand this, right? This is an a plus b squared. And a plus b squared is a squared plus 2ab plus b squared. So 5 times negative 2 squared plus 2 times negative 2 times I times 2 over n plus I times 2 over n squared. That's this thing right here. Let's make this other one afterwards. So we'll make this in pink. So that's this first bit. And then we're going to add in 5 times negative 2 plus I times 2 over n, all of this. So now this is this whole thing in the parenthesis here. We have to make sure we don't forget to multiply by 2 over n. And now I did that one too. Oh, there were lots of mistakes the first time I did this. So now we're going to simplify. Let's write everything out. The limit as n goes to infinity. Sum I goes from 1 up to n. 5 times negative 2 squared is 4. 5 times negative 4 times I times 2 over n plus I squared, I forgot my 5i squared times 2 over n squared. And then we need to add in negative 10 and 5 times I times 2 over n multiplied by 2 over n. So limit as n goes to infinity. Sum I goes from 1 to n. Let's simplify what's inside first. So 5 times 4 is 20. 20 minus 10 is 10. Now what about this? What's multiplied by I times 2 over n? Well, 5 times negative 4 is negative 20. Plus 5 is negative 15. So 10 minus 15 times I times 2 over n plus this 5i squared times 2 over n squared times 2 over n. Everything times 2 over n. All right, so now I'm going to bring in the 2 over n. The limit as n goes to infinity. Sum I goes from 1 to n of 10 times 2 over n minus the sum I goes from 1 to n of 15 times I times 2 over n squared plus sum I goes from 1 to n of 5i squared times 2 over n cubed. All right, why did I do this? So the important thing is these sums, I know how to do the sum from I goes from 1 to n of I and of I squared, but I don't know how to do the sum from I goes from 1 to n of negative 2 plus I times 2 over n squared. So I've simplified this, and I'm going to bring out the constants. So realize there's no i's in here, so that's all a constant. Limit as n goes to infinity of 20 over n times the sum I goes from 1 up to n of 1. Here, most of it is a constant, 15 times 2 squared over n squared times the sum from I goes from 1 up to n of I plus 5 times 2 cubed over n cubed times the sum from I goes from 1 up to n of I squared. So the reason why we like this is we like that we now know this formula, we know this formula and this formula, so we can apply them. So we get the limit as n goes to infinity, 20 over n times, well, what's the sum from I goes from 1 to n of 1? Well, that's 1 plus 1 plus 1 n times, that's just n, minus 15 times 4, that's right, that is 60 over n squared times, now this sum here is n times n plus 1 over 2, that's one of the sums we need to know, and 5 times 8 is 40 over n cubed times, now this sum is n times n plus 1 times 2n plus 1 over 6. Okay, so now we need to simplify. We want to take this limit. And the way we're going to take this limit is we're going to first arrange all the n's all by themselves and all the other constants by themselves. So the limit as n goes to infinity of 20 times n over n minus 60 over 2 times n plus 1 over n times n. And then here we have a 40 over 6 times n plus 1 times 2n plus 1 over n times n times n. And the reason why we do this is because when we take the limit as n goes to infinity, well, n over n is 1. N over n is 1. N plus 1 over n, this is a polynomial. Over a polynomial of the same degree, we just take the leading coefficients. That gives us a 1 as well. And then we have n over n, 1. N plus 1 over n is, again, a leading coefficient of 1 over 1. It's 1. And then here again, we have a limit 2 over 1. So that just gives us a 2. So in the end, when we've taken this limit, the answer is going to be 20 minus 30 plus 40 over 6 times 2. That's 40 thirds. So that's negative 10 plus 40 thirds. Now 40 thirds is 30 thirds plus 10 thirds. So 10 plus 10 thirds. And the final answer is 10 thirds. Okay, so what did we do? We take this, they looked at this integral, we looked at this integral and we said that we want to write it as a limit of Riemann sums. What we need to figure out what the delta x is. The delta x was the length of the interval, 0 minus negative 2 over n, so 2 over n, and that told us what the xi's are. With the xi's and the delta x, we took the limit as n goes to infinity of the sum of this. We did a whole bunch of algebra to get it into a form where we have this sum I goes from 1 to n of 1, sum I goes from 1 to n of I, sum I goes from 1 to n of I squared. And when we do those, we kind of plug in those formulas that we know. And in the end, you do the rest of the algebra, you get 10 thirds. Now the nice thing is that you can always check to see that you're right. And you can do that because we now know how to take that integral. Right, so the integral, let me get a new piece of paper instead of trying to crowd this one. So the alternate way to do this problem is to take, is to first make sure that we have focus. Focus. It's because I don't have much light in this room. I didn't turn on my light. There we are. Okay, so I want to take this integral. And to take this integral, we take the, we say, all right, well, it's the antiderivative of 5x squared plus 5x. So the integral of 5x squared is 5x cubed over 3 minus plus 5x squared over 2. Limit evaluated from x equals negative 2 to x equals 0. Well, so that's 5 thirds. Plug in the 0, 0 cubed, plus 5 halves, 0 squared, minus 5 cubes, so 5 over 3 times negative 2 cubed, plus 5 over 2 times negative 2 squared. And so what do we get? We get negative 5 thirds times negative 8, plus 5 halves times 4. Now what do we get? We get 40 over 3, 20 over 2, 40 over 3 minus 10. And hey, wait, that's what we had over here. Negative 10 plus 40 over 3, which is equal to 10 thirds. Yay! Now, I hope that was helpful, and see you later.